Section 2.4, Intermediate Algebra. In this section, we are going to graph lines that have a slope of 0 or that have an undefined slope. We're also going to learn how to recognize whether the graphs of two linear equations are parallel or perpendicular, as well as how to graph lines by their x and y intercepts. Let's take a look at this first example here. We are given a function f of x is equal to 3, and let's graph this. You can think of this in terms of y equals 3, and to graph anything we have to have some points. So if I put an input value of 0 in here, there's no place to put that x. I get an output of y. So translation, my x was 0, my y was 3. If I try another value, let x equal 1 as an input, there's no place to put it. I end up with an output of 3. So I have 1, 3. If I plot those points, 0 out, 3, 1, 3, and I connect them, what we have is a horizontal line. What about the slope of this line? Well, for the slope, we take the change in the y over the change in the x. In other words, the vertical difference over the horizontal difference. So if I take this y value minus the second point that I found over the first x coordinate minus the second x coordinate, we end up with a 0 over negative 1. 0 divided by any number is equal to 0. And this is true of any horizontal line. And let's summarize that on the class notes. If you have a horizontal line, you will have a slope, which we often let m stand for, of 0. And it comes from equations that are of the form y is equal to some constant value, or we may see it as a function notation, f of x is equal to some constant value. And we just saw that was the case given this equation here. The function is equal to 3. Well, let's look at this next example. Before we graph this, we need to get y by itself. So we will subtract a 6 from each side or take it to the other side. Changes its sign, divide both sides by negative 3 because we still don't have y by itself. The negatives cancel out, the 3's cancel out, and we end up with a positive 2. Oh, look at here. There is no x in here, so if we were going to graph this by the point slope, we have a 0 for our coefficient on the x. How do I know that? It's not there, and the only way for it not to be there is that it's being zeroed out. So whether we recognize this as that special case we just looked at, a horizontal line, or whether we continued further and finding our coefficient is 0, put this together, we have a horizontal line with changing x values, but always the y at 2. So if I let x equal 1, my y is 2. If I let x equal 0, my y is 2. Negative 3 for an x, my y is 2. In all those cases, we end up with a horizontal line at y equal 2 for the equation. Got another equation here that they're asking us to graph. It's always good to get the y by itself. Oh wait, there isn't a y. Well, let's get x by itself and see if we can't plug in some values to graph this. So I'm going to take the 10 to the other side. It's negative on the left. It will become positive on the right, or by adding 10 to both sides. Divide both sides by 2. We end up with x is equal to 5. This also doesn't look quite like the linear equations that we've been dealing with an x and a y term. There is no y here. So when we try to pick some points, let x equal 5 is the only thing that we can let this equal. There is no y on here, and so we can pick any value. And to help you see this, if I put 0 times y here, I could let y be 1 because it's being zeroed out. X is equal to 5. X is equal to 5 no matter. Y is equal to -1. It's being zeroed out. X is equal to a 5. If we plot those points, 5, 1, 5, -1, and any other values that you might want to choose, what we ended up with is a vertical line. This also is a special type of linear equations. And let's summarize that here, at least initially. It's of the form x equals a. And in terms of the slope for this, let me go back to the graph. What about the slope? If we're calculating the slope, we would take the differences in the y, so I'm going to start with this y1 minus this y, which is -1, over the changes in the x's. I started with this y, so I'll start with this x, 5 minus this x. Well, the minus a minus is a plus. We end up with 1 plus 1, or 2 in the numerator, and a 0 in the denominator. When we have 0 in the denominator, mathematically, this is undefined. You get an error if you do this calculation using a calculator or long division. It's not possible. It's undefined. Some textbooks will say that there is no slope, and we have to be careful with just our casual use of English. If I ask, do you have any apples, you might say, no, we have no apples, or we have 0 apples, with the impression there are no apples available for us. In the math world, a slope of 0 is different because it graphs into a horizontal line versus no slope or an undefined slope because it's coming from a vertical line. So to fill out our notes sheet for the slope of a vertical, we are going to say in the mathematical proper correct form, that is, it is undefined. While we're here with the note sheet, let's talk about parallel lines. Two lines are parallel if they have the same slope, or if both lines are vertical. So for parallel, we're talking lines that have the same slope. For perpendicular lines, two lines are perpendicular if the product of their slopes is a -1. Or in the special case, if we have one vertical line and the other is horizontal, we would have perpendicular lines. They meet to form a 90-degree angle. So we're going to express it as the product, which means we're multiplying the slope. So I'm going to call m sub 1 the slope of our first line, m sub 2 the slope of our second line, and when you multiply them, the product is equal to a -1. So let's take a look, now that we know about parallel and perpendicular lines, to see if we can solve this next problem. It's asking us without graphing to tell whether the lines are parallel, perpendicular, or neither. And both of those properties of lines are based on their slope. So our first order of business will be to find the slope. This first equation, if we can transform it into y equals mx plus b, we can readily pull off the slope because it's our coefficient of our x term. So we need to do a little transformation here. We're going to take 2x to the other side, which makes it negative. It doesn't alter the minus sign in front of our y. And because we have the goal of this formula, I'm going to bump the 6 down and put the 2x, or in this case the minus 2x, in front. It doesn't matter. We still would look for the coefficient of x for our slope as long as y is by itself. Y has a coefficient of -1. So every term will be divided by -1, or just change the signs on all of your terms. A negative divided by a negative is a positive. Positive divided by a negative is a negative. So it appears here, this first equation that's given, the coefficient of x, because y it's by itself, is 2, and we have a slope of 2. Same steps for this other equation. I'm going to take the positive x to the other side, which makes it negative. Bump the 5 down, divide everything through by 2, and we end up with a 1y is equal to a negative 1x over 2, or if I pull those apart, negative 1/2 times x. And if you multiply that back, we would have numerators negative 1 times x is the negative x. Denominator of 1 times 2 would be the 2 minus 5 halves. So on this second equation, I'll signify that by m sub 2 is a negative 1/2. Well, for them to be parallel, these would have to be the same slopes. That's not the case. For them to be perpendicular, the product of the slopes has to equal a negative 1, and is that the case? 2 times negative 1/2, a positive times a negative is a negative. The 2 in the numerator cancels out the denominator, and in fact we do get a negative 1. So these two lines are perpendicular, and there's the symbol for perpendicular. We define perpendicular by the product of their slopes equaling negative 1, but also what turns out is one slope is the negative reciprocal of the other. The reciprocal of 2 is 1/2, and it has to be the negative, meaning the opposite of the other one. So we can see, given a slope, what its perpendicular line slope would have to be by taking the opposite or negative reciprocal of the given line's slope. In this next example, they're asking us the same thing. Are these parallel, perpendicular, or neither? To answer that, we need to compare the slopes. The easy way is to solve for y, so taking the x to the other side, or subtract x from each side, and bumping the 5 down gives us the following. Divide every term by 2, and we have a negative 1/2 times x for the slope here. If I pull that coefficient away from the x, so we have a slope for this first line, a negative 1/2. The second equation, we want to get x by itself. Try it again, get y by itself, so we're going to move the x to the other side. Taking it to the other side, it becomes a negative. Divide everything by 2. The 2's cancel out, leaving y. The coefficient of x, at least in the numerator, is negative 1, and divided by 2, so we have a negative 1/2 times x plus the 9/2. And what we're interested in is the coefficient of x to give us the slope, and look at there, it's the same as the first given equation. When you have same slopes, you have parallel lines, and there's the symbol representing parallel lines. We've looked at two ways to graph an equation of a line. One was by plugging the points in. Another way was by the slope-intercept, and we're going to look at a third method for graphing a line by using the intercepts. And I have a graph here that's showing this line that's intersecting the x and the y-axis. Any line that is neither horizontal nor vertical crosses both the x and the y-axis. And we've already seen that the point at which a line crosses the y-axis is called the y-intercept. And in this case, it would be 0, -3 would be the coordinates. Well, guess what? This point here is going to be defined as the x-intercept, where the graph of the line crosses the x-axis, and the coordinate of it is 2, 0. Well, when we are graphing, we can graph an equation of a line by its intercepts. The intercepts involve having, for the y-intercept, an x equal to 0, And to find the y-intercept, or x-intercept, it turns out our y is 0. So let's summarize that here and then show it in an example. Just as I said, if we're looking for the x-intercept, which is a generic form of a some value 0, to find that x-intercept, you are going to let y equal 0. It's like the opposite of what you're working with. We're looking for an x-intercept, but we let y equal 0. And you'll see here, to find the y-intercept, which we saw when we were working with slope-intercept, to find the b, we are going to let x equal 0, so that we end up with that point that lands on the y-intercept. So here is an example to illustrate that. They're asking us to graph this equation by finding its x and y intercepts. So here's our equation. I'm interested in finding the x-intercept. And from our class notes and what I just got done saying, we are going to let y equal 0. So in place of our equation, we will let y equal 0. So we'll put a 0 in place of y. That cancels out, leaving a 2x is equal to 12. Divide both sides by 2, and we end up with 6. If you summarize that, always with your x value first for your ordered pair, we have the point 6, 0, which unfortunately is off my graph, but I think you get the idea. To find the y-intercept, you do just the opposite variable y's, setting it equal to 0, so we're going to let x equal 0. And in this equation, we will replace x with 0 and solve for our y value. Here's the plus with working with zeros. This is gone, leaving us with 2y is equal to 12. Dividing both sides by 2, we end up with y is equal to 6. If we summarize this step, listing your x first, we have a 0x with a corresponding y value of 6. And again, my graph is a little bit off here. We're going to go with 0 displacement on the horizontal axis and a y value of 6. And then it's just a matter of drawing the line between those 2 points, and I've graphed my line. Any one of these 3 methods, whether you plug values in, whether you graph a line by its point intercept, or find both the x and y-intercept, any one of these 3 methods is acceptable for finding an equation of a line. So besides slope-intercept form for a linear equation, another way to determine whether an equation is linear is to write it in the form of ax plus by equals c, which is known as the standard form of a linear equation. We can show that every equation of this form is linear so long as both a and b are not 0. And one little note, if you have an equation in standard form, ax plus by equals c, the slope is equal to the ratio a over b times by -1. In other words, the opposite of a over b. So let's take one final look at applying this skill. And what we have here is problems that are asking us to determine whether the equation is linear. If so, find the slope. Well, this first one is in the form of ax plus by equals c, so there's no question that yes, it is linear. They're asking us for the slope, and we can use that shortcut. The slope is equal to the opposite of a over b. So we've got the opposite. A is the coefficient of x as long as it's in the standard form. So a is 2. B is the coefficient of y. It appears to be a negative 4, and it is. If we change that subtraction into plus a negative, it's clearly a negative 4. We have the two negatives, which gives us 2 4s, positive, and if we reduce it, we would say the slope is 1/2. In this next example, we have function notation. Doesn't look like our standard form, but let's replace the function notation with y, which makes it look better. We want x and y on the same side, so let's get rid of the fraction, having the denominator here of x. That leaves us with x times y is equal to 4. Well, if we look at that standard form for a linear equation, ax plus by is equal to c, the variables x and y need to be added together, not multiplied. So this would not be a linear equation. The next one also has function notation, so to make this easier to deal with, we'll replace that with an acceptable value of y is equal to x. We have the variables on different sides of the equation. To put it in, if possible, in standard form, the ax plus by, I'm either going to subtract an x from each side or take the x to the other side, which changes its sign. It doesn't combine with the y, so we'll just put the plus implicated here or implied here with a no sign, so it's plus 2y is equal to 0. There's no mention of c being 0. The stipulation is that a and b, the coefficients on the x and y terms respectively, cannot both be 0. So this is a linear equation. And to find the slope, the shortcut is the ratio of a over b, and take the opposite of that result. It's already in standard form, ax plus by equals c, where a is the coefficient of our x term. This minus out in front is short for a negative 1. So we'll take the opposite of our a, which is negative 1, over b being the coefficient of our y term, which is 2. The minus times a minus, or a negative times a negative, is a positive, and this simplifies to 1/2. This last one, we don't even need to manipulate it. If you want, you could put the x to the other side, which makes it a negative x squared plus y is equal to negative 5. The problem, and there's nothing that's going to eliminate that x squared, is the fact that we have x to the second power. Our standard form for a linear equation has both the x and y to first degrees, so this would neither qualify for a linear equation like the second example.